Hello everyone. There is another definition left in this section. We learned the derivative of a vector function, right? So here we define the derivative of the vector function as the tangent vector. So it's like when we learn calculus 1, how we find the slope of tangent line, so which is derivative of the function. So here we have a vector. Okay, so for example, here we have this is RT. Okay, give us the path. And we can find at any point, we can find the tangent. Okay, and this tangent vector is the derivative of RT. And we call that tangent vector. Now let's take a look at the definition. If we take the derivative, so R prime T is tangent vector. And if we divide by the length by itself, the length of itself, so it's like this one. You can see it's same as before when we find the direction. Do you still remember? If we use v vector divide by this one, this will be the direction, right? Direction vector, and which is a unit vector. So here, this is called unit tangent vector. Tangent vector. So what is tangent vector derivative? And if we take divide by its length, it's get the unit vector. It's called unit tangent vector. And for the unit tangent vector, usually we define this as capital T. And T means tangent. Okay, tangent. T means tangent. Tangent vector, unit tangent vector. Now let's take a look at the example. Example 5. Find the unit tangent vector of this curve. So I'm going to move this to the right side. Tangent vector to the curve, and this curve is given by this one. RT equals 3 cosine T I plus 3 sine TJ plus T squared K. Okay, so this is the RT. So what is tangent unit vector? So firstly, let's find the tangent vector. So we take the derivative of the vector, which is R prime T. And the derivative of the vector, we just take the derivative of each component function. So negative 3 sine T, 3 cosine T J, and plus 2T K. Is that right? Next, if we want to find the unit vector, we need to divide by the length. So next, we're going to find the length of the tangent vector. So we write down the length. And do you still remember how to calculate the length? Component square, sum of the component square, right? This square plus 3 cosine T square and plus 2T square, and take the square root. And we can simplify this. Actually, this becomes 9 sine T, 9 cosine square T, and the 4T square. And when we combine those two, we can factor the 9 out. And the sine square plus cosine square is 1. So actually here is 9 plus 4T squared. That is the length. So what is our tangent unit vector? Okay, so let's write down our T. We use R prime divided by this one. So it should be negative 3 sine T divided by this I, and plus 3 cosine T divided by the length. And here's 2T divided by root of 9 plus 4T squared. Okay, this is the tangent unit vector. Now we can take a look at the exercise problem. here give you similar vector, which is 2 cosine ti, 2 sine tj plus root 5k. Okay, now I'm going to give you that exercise, but you should try by yourself. R prime t. So here root 5. Okay, so original is this, here is root 5t. Okay, when we take the derivative of this one, should be root 5 and k. And length. Okay, 4 cosine square, 4 sine square, 5. This term sine. And here simplify root of 9, which is 3. Okay, that is the length. So RT negative 2 sine t over 3i 2 cosine t over 3j root 5 over 3k. This is the unit tangent vector. In the future, we will also learn normal vector. So it's kind of like we have a curve RT. So what's the tangent vector? Here. And normal vector in the future we will learn, that is NT, okay, which is normal to the tangent. So I think we finished everything in this section. It's all about derivative and integral.